Here we have question number 3, part B. Again, this question is from 7.3. This is of the format a squared plus x squared. In that case, we put a as a tangent theta. That is the substitution which will work. Here, a squared is 16, so a is 4. Our substitution will be 4 tangent theta. Dx differentiating will be 4 secant square theta d theta. Let's put it in our substitution. X is 4 tangent theta, so 4 tangent theta cube 16 plus x square. 4 square is 16 tangent square theta. Dx is 4 secant square theta d theta. Don't forget to write dx. 4 cube is 64, keeping it out, tangent cube theta. In here, I can factor 16 out. Inside, I would have tangent square theta plus 1. Actually, this 4 also will multiply with this, so that will become like 256, I think, and secant square theta d theta. You guys notice this 1 plus tangent square theta basically can be replaced by secant square theta using our trigonometric identities. 256 integral tangent cube theta. Square root of 16 is 4. And this 1 plus tangent square theta is secant square theta. Square root of that is secant theta. And we have secant square theta d theta. 256. Oh, 256 times 4. So we have 4 times 256 is 1024. Tangent cube theta, secant theta times secant square theta is secant cube theta. So we get back to this trigonometric kind of integral where we have tangent and secant, both are cubes. Okay. If it's an odd power, which is this one is, we are gonna peel one tangent and one secant and put it down with d theta. Okay. We are just peeling one tangent, one secant, put it down with d theta. Okay. Now remaining tangent squares are converted to secant square by formula tangent square theta is also can be written as secant square theta minus 1. So this is 1024 secant square theta minus 1 secant square theta tangent theta secant theta d theta. After that, we are going to use the u substitution of secant theta. Here we have, when we differentiate that, secant theta, tangent theta is the derivative of secant theta. So that's already sitting in the question on purpose, right? So we have 1024 integral u square minus 1 times u square. And this would convert into du. We can distribute this u square inside. That would look like 1024 u4 minus u square du. Now we can integrate easily. 1024 u5 by 5 minus u cube by 3. That's using the power rule. Okay. U has to be put back as secant theta. So secant 5 theta by 5 minus secant cube theta by 3 plus c. We are almost done, but you notice the original question was in terms of x and we are writing the answer in terms of theta. That doesn't work. So we have to convert back into our x format. For that, we are going to start going to our original substitution, which was x is equal to 4 tangent theta. That means x by 4 is equal to tangent theta. If you use the right angle triangle strategy and say this is theta, then tangent theta usually is opposite by adjacent. So this is x, this is 4. That means this hypotenuse can be written as 16 plus x squared using Pythagorean identity. Now the triangle is complete. You can answer secant theta as reciprocal of cosine theta. That means hypotenuse over adjacent. So that will be 16 plus x squared by 4. Okay, we can replace our secant theta now. 16 plus x squared square root power 5. So this will be 5 by 2 by 4 the power 5 times 5 minus secant cube. That's 16 plus x squared power half, but power 3. So 3 by 2 by 4 the power 3 plus c. 1024 multiplies inside will cancel this 4 to the power 5, only 5 left, minus 16 plus x squared power 3 by 2. 4 cube will cancel and will be left with 16 plus c. That's your final answer. You can leave it here, or you can factor 16 plus x squared 3 by 2. But basic integral technique is this, okay? Let me zoom out and show you the whole picture. Here we have the whole picture. So let's quickly go over the whole procedure. We start with our x substitution as 4 tangent theta. We figured it out and then we used u sub technique to get here. We found the integral. We put u back and then we used our right angle triangle strategy to put secant theta back.